The model is non-deterministic. That is, re-clicking on the generate button without changing the input will produce different outputs with varying levels of pacing, emotion, pitch, and background noise. This is by design. This feature is intended to emulate how human voice actors deliver a given text on different takes. You may need to roll the dice multiple times to obtain that perfect take, and it is encouraged that you continue to generate outputs until you are satisfied with the delivery.
The model uses emotional contextualizers, a term coined by this project to alter the pacings and deliveries of spoken texts. And emotional contextualizers and embedding that guides the model during inference toward an output of similar emotional context. Simply put, it is a separate sentence or phrase that informs the model beforehand of the desired emotion of the output. The emotional contextualizer is mapped to a probability distribution using the sentiment analysis model deep-moji, MIT, which gives a nice visualization of the desired emotion. An emotional contextualizer can be specified in the input by adding a vertical bar to have a character speak the sentence "I hate you" in an amorous manner rather than an irate one. One may opt to use the input "I hate you." Take several tries with different emotional contextualizers to ultimately obtain the perfect output. By default, if the emotional contextualizer is not specified, the inferred emotional contextualizer is assumed to be the input itself. For example, the input "I hate you" is functionally identical to the input "I hate you."
The model primarily uses the Oxford English Dictionary's use as English pronunciation model in its IPA conventions. This pronunciation model is the same one used by the dictionary built into Google's search to view the Oxford IPA transcription for a given word. Typing defined word into the search bar. For example, dictionary is transcribed as dictionary, and convention is transcribed as invention. Note the parenthesized phonemes that indicate optional elision subconsciously prevalent in everyday speech. You may notice that certain words are pronounced slightly differently than what you might expect. For example, suppose that you wish to have a character pronounce the word internet as internet with the phoneme T clearly enunciated in between the first and second syllables. The algorithm, however, may tend to favor the pronunciation internet, opting to rely the T the way that most Americans would pronounce the word internet in everyday speech. This phonological phenomenon is known as vocalic flapping. If you wish, you can override the preference by inserting alphabet strings wrapped in curly braces. See, in the case of internet, you would use the input code things. All alphabet vowels must include a lexical stress. See the CMU Pronouncing Dictionary website for more information on alphabet and a list of all valid phonemes usable on the site. Note that this site does not use the Oxford Convention.
The lexicon that the model uses is an amalgamation of various dictionaries, words that have been scraped from both physical and digital references, and generated phonetic transcriptions, while the lexicon contains many obscure and topical words that are not typically found in phonetic references. For example, the word VTuber. It is by no means complete if you find a word that does not exist in the lexicon, or if you believe that a word may be incorrectly transcribed in the lexicon. Feel free to send me an email or tag me in a tweet.